reactions shown here. There's a triple bond that we studied it. That turned into the double bond, right? And then not only double bonds, that's a cis double bond. We just saw the reagent that does it. So I'm pretty sure right now, there's no trouble for you to figure out what is the reagent to use. You gotta remember that later. This is the one that done by the hydrogenation, because eventually you have to add two hydrogen atoms. So that's the hydrogenations. But you cannot do this way. That's the hydrogen in platinums and palladiums. That condition basically reduces any pi bond. Because the triple bond has a two, it will add one. That's the products that we like to make it, but reactions are never going to stop there. Because it also have a pi bonds there, it can react again, and then in the end, you're going to get the completely saturated molecule. Right? So that's kind of a similarity in kilograms. Instead, what you need to remember is this has to be done by adding just 1 mole of the hydrogen, leaving one of the pi bonds behind. And so you got to use the poison catalyst, weakened catalyst, as a windless catalyst. Right? So you need to figure out what's needed, what you need to be done, and then what reaction you know. So it's gonna, you have to match it very closely as possible. So those type of process you need to do. It could be simple like this, or it could be a little bit more challenging like this. We are going to create cis double bonds, but what we're studying is, it's not a triple bond, it's not a single bond, it's another double bond. Basically what we did, trans double bonds, changed to the cis double bonds. How are we going to do it? It will be simple if the double bond rotates. If we have a double bond rotated, this outer chain, you just have to rotate the other way, then you can make that. But you know, double bond doesn't rotate. So this thing has to be done chemically. It doesn't simply change by itself. So it may be hard to figure out from the forward directions because we're going to think about all the intermediates and then might be need to put things together. So in those cases, I suggest doing backward. That's retracement analysis. So instead of going forward, what we can do, what do we need to make this? What sort of reaction do you know to produce cis double bond, right? Then I hope that you remember the reaction that we just talked about. Using the limitless catalyst, you can use a triple bond, and then you only partially reduce. Then you can have a cis double bond using limitless catalyst. The question is, yes, that might be intermediate, and how are we going to make this from that? I mean, some of you may think that I can basically do elimination, take the protons away, and then you're going to keep the hydrogens away, elimination reactions, just like using the molten KOH or the very strong base in high temperatures. It's not going to work that way because this is not a living group, right? But in order to make the elimination works, you got to make something lead with electrons. That's how this molecule is going to get oxidized. So, but there's hydrogens that are going away as a negatively charged. So the reagent that we use, the molten KOH or the sodium amide in high temperatures, is not going to work in this molecule. So what are we going to do? That's the question. What we can do is we can add a living group. We only need to add a living group. That's the only thing that we need. This molecule doesn't have a living group, no halogen there. But if we add a halogen, then they can lead. Okay? So we can probably do the bromination or halogenation reactions. Just simple, just adding up bromine, and then this makes an attack. Of course, it's going to make a brominium ion, bromide attack in the backside. So you're going to have a 2 bromine on those 2 carbon. Now you see there's 2 pairs of HBr we can eliminate. So first pair, this hydrogen and that bromine goes away, then you get the double bonds. And the second pairs, then you get the triple bonds. Sometimes you got to be a little bit clever to make the connection, right? But That's why I told you that this is kind of a very simple, but it's not really simple transformation. These things that need a little bit of a, strategy to make this thing happen. So this is kind of a more than one step to go through, but I really want to think about these type of reactions so you can prepare things like this. What I don't want to see is using HBr. I mean, in adding HBr, you're kind of having a good idea that we recognize the fact that we need the living groups. If you're adding on HBr, yes, you're going to introduce the bromine here. And then, but the thing is, if you treat this reagent to that, it's only the one bromine, so you're going to get double bonds. You're not getting triple bond.